Hello, I'm Robert Van Voorhees. I'm a solutions engineer in Tanzu public sector. I work with our federal customers and help them be successful on Kubernetes. Today I wanted to do a quick demonstration of how one of our customers runs their clusters at scale and some of their cluster operations to sort of tease out the art of possible and what you can do with Carvel leveraging TKG, TAP, and Tanzu application catalog. So one of our customers has a problem where they can't actually get kubectl access to a lot of their production clusters. So what they did was they leveraged Cap Controller to effectively do all of their day one and day two operations for them. So their clusters run leveraging a series of app CRs and package installs with a Cap Controller, and that does everything from onboarding teams to creating those teams clusters to creating workloads and running applications in production. So I wanted to go through sort of a quick scenario that shows how that works in Tanzu application platform and how everything sort of is leveraging those Carvel tools symbiotically to create a very similar experience, whether you're using TKG, Tanzu application catalog, or TAP. So I've onboarded myself as a new team into this environment. And the way that works is that I effectively give my team a name, which is Phantom, and where I'll go for my actual cluster definitions. I've already gone ahead and done this, and the team's onboarded, and I have this repository checked out. And I've already created a couple different clusters in that environment. I have my view cluster, which has TAP installed on it in the view profile, my build cluster, and then my actual management cluster, which I've called Phantom. What I don't have yet is my runtime cluster to actually run my applications on. So what I've done is I've gone ahead and created a merge request into this environment where my clusters are installed to go ahead and create that runtime cluster. What's happening here is I give the cluster a name, and everything else basically just defaults, but I actually want to turn on auto scaling. And then the other cool thing that they do is they give each cluster a place to go for follow instructions. So I'm telling this cluster to go to this repository, the apps repository, and look inside the stack runtime folder for its follow-on instructions, and it'll just look in the main branch. So when I merge in this merge request, nothing should happen right away, because it has to actually get tagged and released. Now that can optionally be changed so that it would just get spun up when it came into the main branch, but for now I'm following good release processes. So if I come back and look at my clusters, nothing's really happening right now. But if I go ahead and go ahead and create a new tag, so we're just going to go ahead and create the V8 tag, V9 tag I mean. And I'll create that tag. And so now we'll see that there is a V9 tag here. So if I come back over, it's going to take a second to actually reconcile against that new tag. So I'm going to use the Cap Controller CLI to kick that app, and actually we get to watch it, and we'll see that it got the new contents of merging that add runtime and domain, and it was properly tagged as 9. And so what's happening here is it's updating the cluster list, and that secret is then going to get transferred out so that I can create my new cluster. And there's going to be a lot of pausing in this video, so I will let's check what's going on. Here it is. There it is, my runtime cluster. Start provisioning 30 seconds ago. So what I'm actually going to do now is I'm going to pause, because it does take a couple minutes for the load balancer to come up, and you can see that the load balancer is starting to come up, but it's going to take a while for DNS to get reconciled and the instances to actually start up. So when we get back, we'll jump into what's going on when this cluster gets created. See you soon. So we're back. The cluster is just coming up now and is starting to run. And what we'll see is now that the cluster is up, it's created the necessary secret inside of the management cluster, the kube config, which I grabbed so that I can actually start looking in. And it's important to note that I'm not actually doing anything right now. I'm just looking at what's happening and the automation that's taking place for me. So now that this kube config exists, there's a couple different apps that are running in the management cluster. Oh, this is the runtime cluster. It doesn't have cap controller yet. So if I look at the management cluster, there is a couple different apps that get created when I create this cluster. And you'll see that they're starting to just sort of get their bearings as well. And this first app is going to install Antria on the cluster, and we should start seeing that coming up in a minute. The next thing that's going to happen is it's going to install Cap Controller, and then it's going to install something we call stacks. These stacks are the common applications which are applied to every single cluster that comes up. This common app stack is what we consider necessary to get a Kubernetes cluster production ready. So at different customer sites, this is going to install a whole host of different security and logging and auditing things. But right now in my environment, it's mostly just applications to help get you started. So things like Cert Manager, Contour, External DNS, Metric Server, Pinniped. All of this stuff is part of the core or standard TKG repositories, which, by the way, it also installs. So it'll install the TAP repository, the standard repository, the RabbitMQ repository, the core repository, and the Phantom repository. So the Phantom repository is a custom-built repository that includes different parts from Tanzu application catalog. So in the case of one of the common apps, Kayam, that's not actually included in standard or core, and so Kayam is actually coming from VMware application catalog. So there's a bunch of other applications in there, and once these applications get installed, then it's going to install the stack that I specified when I declared the cluster. So I didn't specify the common stack. It gets installed on every cluster, but the specific runtime stack that I asked for is going to install TAP with the run profile. So that's just going to do a simple install of TAP and actually set the profile to just run. What is going to happen then, if we check back in, we'll see that some of these apps are getting installed. So I'm going to pause since this takes a while, and we'll check back in as these applications start getting installed. So I was a little impatient, so I used the kick command again, just to kick some of these apps so that they stop failing and start actually showing. And so Antria is now coming up, and it's starting to run the controller and the agents and everything. So the next app that's going to happen is Cap Controller. That's then going to install Cap Controller. So if we look at it again, you'll see now it's saying that Cap Controller is reconciled as conceded. So if I come back over to the runtime cluster, you can see the Cap Controller is up. And now you'll see that the apps for these applications are actually on the runtime cluster itself. So I'm going to pause as some of these start to come up, and we'll check back in. So a lot of these applications are now starting to come up. We got Cert Manager, External DNS, Metric Server, and then the TAP applications are sort of failing because we still need to wait for Cert Manager and Secret Gen Controller to finish reconciling. At this point, the cluster has existed for about 12 minutes. So the pausing, I'm not pausing for a really long time, just pausing for a couple seconds while that stuff sort of kick its way along. I'm going to pause again. Okay, so we're just checking in again. The cluster's been up for about 17 minutes. At this point, most of the apps are reconciling or succeeded in reconciling. So now the TAP runtime profile is being installed. So you see that Cert Manager, Contour, External DNS, everything else in the common stack has been up for a few minutes now. And we're just starting to see the runtime profile. So what I want to do is I actually want to jump back over to a different cluster that's been up and running now, which is my build cluster. So this thing's been up for about 3 days. It's reconciled all stuff to its steady state. And you can see it follows the exact same process of reconciling different things. Did I actually build cluster? So what I want to do now is I'm actually going to follow that similar process of merging in something, and I'm going to onboard a new development team. And so this new development team is going to actually merge into the build stack cluster, and I'm going to bring on Spring Pet Clinic, and I'm basically going to say, hey, this application team is going to keep their source code in this repository in GitLab, and they are going to be a part of this runtime cluster that we just stood up. And when it's done, I want that deliverable to actually get pushed into the runtime cluster and start running. So I'm going to go ahead and I'm going to approve this merge request. And now when I come back and look at this stack for the build cluster, not the runtime cluster, but the actual build cluster, I'll see that it has onboarded the workload here for Spring Pet Clinic. So it might take a minute or two, but if I come back over and look at the runtime cluster, you'll see there's no workloads because I'm on the runtime cluster. But if I come back over and look at my build cluster, you'll see that the team's been properly onboarded. So it's going to take a minute or two for it to run through because it's actually going to do the whole test everything process. So I'm going to pause it again. You'll see that it's going through the tests right now, and then it's going to do the source scan, and then it's going to do Tanzu build service, and then it's going to do the image scan. So I'm going to let that run, and I'll check back in when we're a little further along. Okay, so the Tanzu build service is just now finishing up, and we're starting to run that config writer. And so what's going to happen is we are getting the deliverable, which is the service that was created with the Tanzu build service image. We are packaging that up, and then we have actually pushed it into the we've pushed it up into a different branch in GitLab. So if I actually come back over here now, I should see in the runtime branch, I have added this new commit to point to my latest built Spring thing, the new deliverable. So this deliverable was shown as a merge, is now as a merge request into my actual runtime cluster. So what I'm going to do is I'm going to go ahead and I'm going to merge this. I'm going to create the merge request. And we're going to merge it into, oops, hold on, sorry about that. I had a merge conflict in there since that branch had previously existed. So I resolved the merge conflict. You can now see that it's adding the actual deliverable. And if I was to add in service bindings or anything else, those would all show up here. But this is just a simple single application. So I'm going to now merge this in. It's been merged in. And now we should see in our runtime cluster the container for Spring Pet Clinic is actually starting to come up. And the error. All right, but other than the fact that there's an error on it, which I'll have to figure out why there's an error, you can see that it actually went and was applied as a workload into the, or as a K service into the cluster. So I'll have to figure that one out. But still some kinks around this, but the whole cluster did come up. Whole cluster installed the tap runtime fully, and it's about 22 minutes in. Got a fully up and running runtime cluster with a workload being deployed out onto it. So thanks for watching.